I'm going to introduce some subjects, but as I go along, I'll ask you to work with me to have some experiments and do some experiments. In order to do that, I need to just check that, for those of you who want to work along with me, that you've got the right things installed on your machines. If you're going to do these exercises, you need some kind of photo editing software. So if you've got an open source one, or you've got something like Photoshop, that should be enough. But even if you've got Microsoft Word, you should be able to put some images together and do things like change their contrast and things like that. So you need a photo editing application. Failing that, as I said, do something in Word perhaps. And lastly, we're also going to be just doing some introductory things in Unity. I'm not going to give you anything comprehensive as far as doing things in Unity, because what I want to do is just solely focus on AR markers and creating them, designing them, and optimizing them for use in AR applications. So this is not going to be a tutorial on Unity as such, but we will be going into it to test out some things. And lastly, in order for you to test out some of the markers, it will be good if you have access to Vuforia online. So if you don't have an account with the Vuforia AR software or platform, then what I advise you to do now is go to the Vuforia website, get yourself an account, and then when we work with the markers and test them later on, you'll be able to work with me on those. All right. Next thing I want to look at is how you go about actually producing and getting ready for implementation with these particular kinds of targets, specifically looking at optimization. Now, in order for this kind of work to be done, I probably spent most of my time doing this because the images didn't have enough contrast, there weren't enough identifiable features, and I had to keep adjusting things until the rating, star rating, as far as Vuforia was concerned, went up. And one of the things you'll see in Vuforia is it actually shows you all the identifiable features on your target, and you can see exactly how many there are. But as I said, just having a lot of identifiable features is not enough in itself. There need to be the right features. There needs to be the right distribution of them in order for it to be trackable as well. All right, so I'm just going to pause for a moment, and I'm going to ask you to just do a little exercise, which is just want to go to the internet and go to Google Images and just find an image. It doesn't need to be anything special. It could be a picture of a person. It could be a picture of a building. It could be absolutely anything. I just want you to try a test with the image that you're going to get. If you haven't got, as I said, an account with Vuforia, then it's something you can possibly try in a moment and get, because a lot of the testing that we're going to do in this instance will be using Vuforia's facility, which allows us to test whether an image is augmentable or not. What I'm going to do is just go to the internet, and then I'm going to take that image, I'm going to load it up onto Vuforia, and I'm going to see exactly how augmentable it is. I'm just going to pick one at random. Okay? So let's get your glasses on here. You can follow through with me if you want to. Vuforia is an online platform that provides a toolkit for you to create augmented reality experiences through things like Unity. So go to the website, Vuforia, get an account, and I'll show you how you can test whether an image is augmentable or not. Okay? You don't need to download it, you just need to get an account on the website for this, okay? I'll show you. I'll bring it up, and you'll be able to see. So I'm going to go to Vuforia website. I've already got an account, as you can imagine. And I'm just going to log on. If you've got an account and you've registered and you've managed to get on board, then there's two things you need to do in order to start using the facilities on this. Typically, you need to get a license to use anything that you're going to do through Vuforia. And under Develop, there's a section where you can get a key or a license to actually use in your application. So I'm just going to log in. Okay, it's not loading. Okay. All right. Okay, I'm just going to show you what to do. Seems my connection is a bit short. I've already got lots of licenses here, but you can just create a new one. Under Develop, you'll see License Manager, and you can just get a new key. And that's as soon as you push that button, it'll ask you some, give it a name. I'm just going to call it Oxford in this instance. And then I'm just going to put the agreement and confirm. And now that's a license key I can actually use within Unity and other things that might be building apps within. So that's important to get hold of. All right. Once you've got a license, you can create a database of augmented reality targets and images that can be used in augmented reality experiences. I've already got some here, so I'm just going to use ones that I've already got. So here's something I used with post-production students a little while ago. And you can see my previous targets I've got here. I've got a photograph that I took, and you can see it's got a rating of 4 stars there. But what I also did was I took a scan of an object, a knife sharpener as well. So it's a 3D object, and that's in there as well. But if you want to test something, all you need to do is simply add a target to a database that you've already created. So in my case, I think what I'll do is just pick one I've already got. I'm going to just browse. And I'm just going to pick that one that you were looking at earlier. In my case, the Leonardo image. And I'm going to just say what width it is. I know it's 0.565 meters. The units that are used here by Vuforia, they're the same scale and system that Unity uses. So it's always typically meters. So this particular poster was just over 0.5 meter wide, which is why I've given it a width of 0.565. It'll naturally work out what the height is based on the proportions it has for the image, if I give it the width. All right, so I'm going to add that. Now, in this instance, I didn't check or do any optimization on that image. I just uploaded it. It might be that it's huge. It might be 50 or 60 megabytes in size. Maybe it's 32-bit color and a whole host of other things. I didn't do any checking on it. So we'll see how well it performs, and we'll have a look at its qualities in a moment. Okay, so you can see, actually, this one, as I think I did actually mention, this is the one that we tried to add the markers to in order to make it more augmentable. And you can see it's been given a 5-star rate. Okay, as soon as it's loaded, sometimes it takes a bit of time to process, and it will just say processing. And after a while, if you refresh the page, you'll see it's been given a rating. If you actually click on it, the target that you brought up, it will show you it, and you can actually show the features here at the bottom. Click on that, and you can see that's got quite a lot. All the little yellow crosses, they're all uniquely identifiable features that can be used for recognition and for tracking. And what you'll notice about them is they're very distributed all over the image. They're not localized anywhere. They don't seem to be regular at all and repeating in terms of their patterns. There doesn't seem to be... It's possibly, if you look at it from a distance, there could be symmetry associated with this. But there's enough separate, detailed features there to make this not just easily recognizable, probably easy to track as well. So this is the way that you can test your augmented reality images. Typically, just come up to Vuforia, log in, and go into a database of targets you've already created, upload your image, and just see how well it does. Now, you might find that it's an image like this, but that it doesn't come up with 5 stars. And that could be something for a whole bunch of reasons. Okay? And I'm going to go through a lot of the other possibilities as to why an image might not appear to be augmentable, even though it appears to meet all the basic criteria. That's where you need to do some refinement and some touching up with the image in order to just get that extra star out of it if you can. Actually, try this now if you want. If you've got a piece of paper, actually draw a target that you think has got all the ideal features in it. All right, just with a pen and a bit of paper, okay? And take a picture of it with your phone and send it to your computer or get it onto your computer and upload it to Vuforia and see if all the decisions you made about designing an ideal AR target actually worked. Okay. While you're doing that, I'm just going to show you one that was done earlier, courtesy of some of the students at Ravensbourne. And you can see exactly what happened. Let's go back here. You might find that circular images, which have got details within them, as I said, things like mandalas, they can still be quite easy to recognize. But even then, I think with Vuforia, the focus is on recognizability. That's really what that score is about. It's not necessarily about trackability. Okay, so at a first port of call, it's useful to get this, but tracking and stability is something you typically won't know until you've tested it out in the real world, or you've taken into account in advance not to include features that reduce trackability, like repeating patterns and symmetry and things like that. Okay. Now, I asked the post-production students to create a drawing that we were going to make a model of, and I said, right, you've got a choice. You can make your object, whatever it is, make it of cubes and spheres, okay? And you've got a maximum of 9 that you can use. You can have 3 spheres if you like, and 6 cubes, or you can use 5 spheres and 4 cubes. It's up to you. They can be different sizes, whatever you want. All right, but you've got a maximum of 9 objects, and you must use a mixture of spheres and cubes. And they basically did a sketch on a piece of paper, and I asked people what did they create, and one person happened to create something that was remotely like something like a car. This is what they created. And amazingly, it got 4 stars in terms of its recognizability. Now, I should say this is a little bit of a cheat, because I actually adjusted this image. Before I adjusted it, it was 3 stars. But because it was a photograph of something on a piece of paper, its contrast in terms of foreground and background wasn't as good as it could be. So what I did was I took it into Photoshop and I just increased the contrast. So the background is more or less white in the end. And when I brought that back in, it jumped up to 4 stars. Okay? So just making that one change, as I said right at the beginning, one of the most important features is having high contrast between foreground and background. That's a really important thing. And I just made that one change and increased the recognizability of it up by 1 star. And it was enough for it to be suitable for using as a test in an augmented reality experience. Having got this image and putting it up on Vuforia, it's actually ready to be packaged and be put into an augmented reality experience that can be created through things like Unity, for example. Now, in a moment, for those of you who want to follow, I'll show how this image, or the one that you've got, that you might have picked, for example, can be used within Unity. I'm not going to go into Unity per se. I'm literally just going to show you, here's how it would be put into Unity and be used to create an experience, and that's it. So that target was something that I downloaded, and I found I could use it within Unity. And what I did within Unity, just to go to the next stage, was I actually built that within Unity as a 3D model. So, it's only spheres and cubes, so it's easy to create 4 spheres and a number of cubes and put them on top of each other. And then that was a 3D model I was going to get to appear on top of the target once I'd create the augmented reality experience. So anyway, they'd done this sketch, and I created the 3D model, and then what was at one point just in someone's imagination was now a 3D model showing up in the world. And I managed to save it as an augmented reality Android app, so they could start using their phones and their camera on their phones to look at the target image that the person had just drawn, and as they did, a 3D model appeared on their phone. We also saved it up for the HoloLens, and the person who did it, I got them to put the HoloLens on and got them to look at the target on the screen, and the whole model, 3D model, came out of the screen. So this is all done within about an hour or 2 of teaching. If it was done without me having to explain it all, it would have been probably done in about 15 minutes. Because all that would have been done was, the sketch would have been done, I would have taken a photograph, loaded it up onto HoloLens, onto Vuforia, made it an augmented reality target and downloaded it, put it into Unity, and then once I'd created the car and the model, the spheres and cubes, simply just saved it as an Android app or a HoloLens app. And that if it was me doing that, there's no coding involved. It's just literally drag and drop. And that was all done within I would have been able to do that within 15 minutes. Okay?